Hello students, welcome back. Let us resume our discussion in section 2. And we completed 2.3, I believe. Let's go to 2.4. A similar problem here with a little bit more complicated graph, I have to say. Determine the domain and range. Let's see, domain is all possible x values starting from this solid dot. -1 all the way to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So is the domain -1 to 9? Actually, not really. Not everything between -1 to 9 will suffice because there's a gap. -1 to 1 to 3, and this one is emptied out. And then union, and then let's see, restart at 5, but this one is emptied out as well, so 5, and then going all the way to 9. That's the domain. See that? If you miss this empty, then there's going to be a bit of a deduction, but losing a little bit like that here and there will not kill you. But the main structure is starting from -1 and 1 interval up to 3, and the second interval from 5 to 9. That's the main structure. Solid dot means bracket here. Empty dot means parentheses. And I'm moving horizontally only because I'm looking at the domain. So don't pay attention to y coordinate moving up and down. Just look at the x coordinate. So that's the domain. Let's call it D. Alright, how about the range? It's going to be trickier. You have to look at the y coordinate. What's the lowest? -2, and it goes up to 1, 2, 3, 4, 5, 6. Is that it? Is there any gap this time too? I'm afraid there is. So not every y coordinate will suffice. Start from -2. And then it goes up to maximum how much? Not the maximum, but local maximum, up to 2. So +2. And please note that this is emptied out. And then restart, let's see, y coordinate 3. Alright. And then go to maximum 6. Now does it make sense? This tree, this point is not emptied out, so this is bracket. We have this parenthesis here because this point is emptied out. And this point is emptied out, but that's okay. It's going to be covered by this part. A bit tricky for range, but you can answer like this. Let's see, what did I do in my answer key? The domain, yes, same domain, and same range. And do I have some further graphical explanation? Okay, domain, we are moving horizontally, so look at only the x coordinate. So green region, we have some graph. This pink region, we have another graph, but we have a gap, the white region. X coordinates start from -1, bracket, and end with +3, but this is emptied out, so parentheses. Restart at +5, emptied out, so parentheses, end at 9, bracket. Make sense? Next, how about the range? Start from -2 to +2, but this is emptied out, so we have parentheses, and we have a gap. Restart at 3, and this is bracket because this is part of the graph, and just covers all the way up to 9, bracket again. This one here is going to be buried. Now, what if I change the problem a little bit? What if this graph had been a little bit different? Similarly like this, but like this. instead of that, if it comes all the way down here, then what's going to be your range? Y-coordinate begin from -2. And then this time, is there a gap? Well, we're supposed to have ending right here at y equals to 2, but no, it's covered right here. And then resumes all the way up to 6. So we just have one interval. So depending upon the shape of those graphs, we may have very different interval structure. You see, we have two curved pieces, two separate curved pieces, so the domain consists of two intervals. Bracket, parentheses, those can be tricky, case by case, which one is emptied out and which one is solid, because of those. Now range, that behaves very differently. Even if we have two separate curves, we still have just one interval. Range behave very differently. Domains, if you have 5 curved pieces, all separated out, then you have 5 intervals. If you have 4 curved pieces separated out, then you have 4 intervals. Range is all case by case. You have to consider one graph at a time. Range is trickier. Okay, so much for part A. Next, the average rate of change. Well, I hate this problem. You have to know the average rate of change formula, otherwise you can't answer this question. What is the average rate of change? F of 9 minus f of 6 divided by 9 over 6. 9 minus 6. Oh. Okay, let me try again. Divided by 9 minus 6. That's the average rate of change. And of course, average rate of change for 6, 9 as a matter of fact. In general, the average rate of change formula is going to be like this. F of b minus f of a over b minus a. Some people call it difference quotient or even Newton quotient. Average rate of change, yeah, that too is widely accepted term. But that's just a formula, and if you just plug it in, you can answer the question. Look at the denominator, 9 and 6. A value is 6, B value is 9, so 9 and 6. Denominator is clear. F of 9 and f of 6, you have to answer those by looking at the graph. F of 9, how do you find it? Stop the playback and find out. And f of 6 as well. So did you find those? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the last. And then move vertically up. Get to the point, and what's this y-coordinate value? And then f of 6, 2, 3, 4, 5, 6 right here. And then move vertically up until you hit a point on the graph. And what is this y-coordinate value? That's how you can find out the function values, just like you did in 2.3. Start from the x-axis, find the x-coordinate, move vertically until you hit the graph, and then read the y-coordinate by moving horizontally. Points on the vertical line share the same x-coordinates, so no change in x-coordinates. Just move follow and then find the point, and then find out the y-coordinate. So horizontal line, points on the horizontal line share the same y-coordinates, so move horizontally like that. So that's what you're going to do here. Oh, it's a slope of secant line? No, that's not that important. I wanted to see the vertical lines as a matter of fact, but apparently I didn't give you that. Okay, I'll do that. So start from 6 here, and then find the point, and then, so what's the function value? 1, 2, 3, 4. So the function value is 4. No, this is wrong. So this one is 4. And then, alright, so from 9 is up here, and then move up, and then move horizontally, and that's 6. So this quantity here is 6. So what do you get? Looks like in the end you're getting 6 minus 4, that's the numerator, and then the denominator is 9 minus 6. Denominator is just b minus a, so you don't really have to read the graph. But the numerator, f of b minus f of a, you have to read the graph to find out. Okay, solve the inequality f of x is less than -1. Find all x values in which f of x is less than -1. Y is -1, so where is that line? So y equals to -1 is right here. And then less than -1, so down below. So we want part of the curve that goes down below. And then we have to discard all part of the curve that are above this. So which x-coordinate will give you this part? Greater than what and less than what? Do you see you're going to get an open interval 0 to 2? Why open interval? Because f of x is less than 1, -1. Less than -1, excuse me. It's strictly less than -1, not semi-inequality. So we're going to empty out the endpoint. So we have x moving from 0 to 2. Oh, lousy drawing. I'm ashamed. Let's get out of here. Instead, I'll show you my answer key. Here, below y equals to -1, so down below, and we're looking at only this portion of the graph, disregarding the rest. X is moving from 0 to 2, and endpoints are out because we have strict inequality. If this problem had been f of x is less than or equal to -1, then both have been solid dots, and we'll have closed interval, a bracket 0 to 2. See the subtle difference there? Okay, that completes example 2.4. Okay, let's talk about the next example in a separate video. We are going well.